I finally did it. I got myself a mini lathe. And you might be heading to the comments right now to ask, why would you need a mini lathe when you already have a big lathe? Which I'll admit is a fair question. And the truth is, I have actually been working on this for quite a while because I know that I am incredibly fortunate to have access to big machines. And I know that there are a lot of people out there who are either doing hobby machining or looking to get into hobby machining who just don't have access to industrial sized machine tools for any number of reasons. So there are a lot of people out there doing hobby machining with the smaller sized import machine tools, especially the mini lathe. If I had to guess, I would say that the mini lathe is probably one of the most popular and ubiquitous machine tools available today. And for that reason, I've wanted to get one of these things into my shop for a long time. And now I finally have one. Of course, full disclosure, Vevor did send me this thing, but like I mentioned, I have been working on convincing them to send me one of these for probably the better part of a year now. And now that I have it, there's just a bunch of different stuff that I want to do with it. So hopefully what you're watching now is just the first in what will eventually become a whole series of videos about the mini lathe. But this video is all about day one. Our new machine has just arrived, we've taken it out of the box, and now we need to get it set up and ready for work so that we can take our first test cuts. But after pulling your machine out of the box, the first thing you're going to notice is that it's covered in this thick layer of grease. This is, of course, to protect it from corrosion during shipping. But now that we have it, the first thing we have to do is get all this stuff cleaned off. And in my opinion, at least, the very best way to go about doing this is to disassemble the entire machine down to all of its individual components so that all those different pieces can be cleaned and addressed individually. I have never disassembled one of these machines before, so to tackle this, I'm just going to start with the biggest, most obvious pieces first, and then just sort of work my way down from there. There are a couple of different benefits to doing things this way. The first, and I think, of course, the most obvious, is that this is really the only way that you're going to be able to get underneath of all those surfaces and to get into all those different little crevices and slideways and just really get the machine clean. Additionally, this is not a very complicated machine. It's relatively simple in both its construction and in the way that it functions. So by taking it apart like this, it's going to give you a really good opportunity to become familiar with the machine and how it works mechanically. This way, when we're using it for projects later on, if anything goes wrong or you need to troubleshoot anything, you're going to have a lot more confidence and some kind of idea as to how to go about troubleshooting any potential problems that may arise. And there we have it, all of the individual parts neatly laid out on the drip pan and ready for cleaning. And honestly, I'm not going to waste a lot of your time talking about cleaning here. I'm sure that you already know how to clean stuff. However, I will say that a little bit of WD-40, an old toothbrush, and a handful of shop towels will really go a long way here. Personally, I would avoid things like solvent-based cleaners and degreasers. You don't really want to strip the metal bare and leave it susceptible to oxidation. So WD-40 is going to do a great job of cutting the grease while also leaving behind a thin protective film. Also, since everything is already disassembled, this is a great opportunity to clean up any rough edges or sharp corners using a file or a little bit of sandpaper. All right, so all of these individual pieces, they're now cleaned up, degreased. I've gone over some of the sharp corners and edges with a file, and I'm ready to start putting everything back together. But there are two main things that we want to focus on during the reassembly. The first thing is going to be proper lubrication. As we put all of the pieces back together, we just want to make sure that they're lubricated well and properly. So there's really only two different types of oil that you probably want to keep on hand in the hobby machine shop, at least for your hobby machine tools. And the first of those is going to be what's called whey oil. This is the oil that you're going to use to lubricate all of your ways or sliding surfaces. So for instance, like the main bedways here and all of your different dovetails, this is the oil that you're going to use to lubricate all those surfaces. Often also referred to as Vactra oil number 2. This is an ISO 68 oil that is specially formulated for those ways and sliding surfaces. This stuff is really easy to find. Just search for whey oil on any of the major online marketplaces and it should come right up. The second type of oil that I recommend, and I know a lot of other people use this stuff too, is AW68 non-detergent hydraulic fluid or hydraulic oil. This is going to be your more general purpose oil. Basically, if it doesn't take whey oil, then you can use this stuff. So for instance, all your different splash gearboxes, you can fill those with this stuff. Low pressure bearing surfaces, like for instance, this little bracket that holds the lead screw down at the end of the bed. Basically, like I said, if it doesn't take whey oil, then you can use this stuff. The second thing is going to be giving a really good first initial adjustment to all of our different gibs and moving parts. We want to make sure that everything is tight so that it doesn't jiggle around on us, but so that it still moves freely in whatever direction it's supposed to move. We're now ready to reassemble, and I'm going to start with the saddle. So first, I'll liberally apply oil. You'll notice that the saddle here has two gibs, one on the front and one on the back. These basically act as clamps that interface with flat spots on the underside of the ways on either the front or the back. You want to tighten these enough so that the saddle doesn't jiggle up and down on the ways, but so that it's loose enough as to allow the saddle to slide back and forth in its direction of travel. Something important to keep in mind here is that you are not going for perfection. Tightening gibs is definitely more of an art form than it is a science, and there is a lot of feel involved. So just take your time. Don't be afraid to go back and forth. You may have to re-loosen things after you tighten them. Just test, retest, get it to a point to where it feels good to you. And when it feels good to you, you are good to go and you're ready to move on. The next part that I'm going to install is going to be the apron, but before I do that, I am going to go ahead and very liberally lubricate this gear shaft while I still have access to it. Then once that's done, I can go ahead and slide the apron back onto the lead screw. Once the apron is back on the lead screw, I can then resecure the lead screw to the lathe. And at this point, I don't really want to make you watch me reassemble this entire lathe, but these first couple of pieces here do pretty much need to be assembled in the order that you're watching here. And the reason for that is because as far as the saddle's concerned, you can't access the front gib of the saddle once the apron has been installed. And you can't install the apron, obviously, once the lead screw has been secured to the lathe. But once this main carriage assembly has been installed and adjusted to your liking, everything else is pretty straightforward and intuitive. You're basically just working from the bottom up. So next, of course, is going to be the cross slide. It's more of the same. Install the cross slide, adjust the gibs, get the slop out, make sure that it moves freely in its direction of travel. Then, of course, the compound, which, again, install the compound, adjust the gibs to your liking. Once that feels good, you can move on to the tool post and finally the chuck. One quick note about the chuck: if you marked the chuck's original location when it was installed, you can just go ahead and line up your original tick marks here so that it's installed the same way. You know, I got to admit, all cleaned up and oiled, this thing's actually starting to look pretty darn good. I think we're just about ready to take our first test cuts at this point, but before we get to that, there's still one more thing that we need to take care of, which is we need to get our machine firmly mounted to our workbench. This lathe does come with these 4 little rubber feet, and I don't know, I guess the idea is maybe you install these feet and they're supposed to help isolate some of the vibration and keep it from sliding around. But honestly, I don't really see that happening. In my opinion, this machine really does need to be bolted down securely, not only for safety reasons, but it's a small machine, so probably the heavier the workbench you can find, the better. It's just going to benefit from being bolted down securely. On the upshot, there are already 4 threaded holes in the feet for mounting those little rubber pads that we can take advantage of for bolting down the machine. And the chip pan has the matching hole pattern that we can use to lay everything out on the bench. All right, this thing is now rock solid. I mean, it ain't going nowhere, which is exactly what you want. So we are ready to start cutting some metal, which means it's time for a very, very brief conversation about cutting tools. Now, there are a ton of different types of cutting tools, but when it comes to the hobby machine shop, I think there's really just a couple of main categories you're most likely to come across, and those are going to be ground tools and insert tools. Starting with the ground tools, again, there are just really 2 main types you're most likely to find. The first is going to be high-speed steel, and the second is going to be brazed carbide. High-speed steel is exactly what it sounds like. It's just a chunk of high-speed steel that you can then shape and sharpen into a variety of different types of cutting tools depending on your purposes. High-speed steel is relatively cheap, especially compared to most carbide insert tools. It's pretty easy to find. I come across this stuff at flea markets and yard sales, and it's really easy to work with. Once you get used to it, you can shape and reshape this stuff relatively quickly. Brazed carbide is kind of similar, except with brazed carbide, you just have a small piece of carbide that is brazed to a piece of steel. So you have a lot less cutting material to work with. And for that reason, with brazed carbide, you normally are just going to use it in whatever shape it comes in. You're not really going to be reshaping it. It's also a lot more difficult to shape, but you can resharpen it relatively quickly and easily as long as you're keeping the same shape. The other benefit to both types of ground tools is that you can get them very, very sharp. A lot of insert tools, they're not really sharp. And I think for a lathe this size, I have a feeling that having a sharp tool is probably going to be a good thing. So I think that we are going to use ground tools for our experiments today, but we are going to just quickly talk about insert tools. And you probably already know what these are, but you know, insert tools just use a disposable carbide insert. Carbide inserts come with all different types of geometries. There's all different types of tool holders. We're not going to get into that, just like we're not going to get into, you know, how to grind different types of tools today. But carbide inserts are always an option. Again, I think if you're going to go with insert tools for a lathe this size, personally, I would look for inserts that have a sharp edge, which again, I just think for a machine this size, I think that having a sharp tool is going to be a benefit. So we are going to stick to the ground tools today. Once you've decided which tool you're going to use, of course, put it in your tool holder, and then you need to get the cutting edge, the part that's actually going to do the cutting, up to the center line of your lathe. A quick and easy way to do that is to use the 60-degree dead center that comes with your lathe. So this is a 60-degree number 2 Morse taper dead center, meaning the shank here is a number 2 Morse taper, and then this point here is a 60-degree point. Simply put that into your tailstock, then bring the cutting tip of your tool right up to the point of your dead center. And you want these to be at the same height. And if they aren't already at the same height, then you just need to raise or lower your cutting tool. You can see here that I have used a couple of shims to raise up my cutting tool because it was a little bit low. All right, and with that, I think we are finally actually ready to get started. So I've got 3 different types of material here that we're going to test. I have a piece of aluminum, 360 free machining brass, and finally a piece of 1018 cold roll steel. For the test, I guess we'll just step through each one of these materials, and for each material, we will do a series of progressively deeper cuts, maybe starting at like 10 thou and going up to 50 thou, and just kind of see what the machine can handle. All right, so I guess without further ado, as they say, there is no time like the present to get started. And of course, first up is the aluminum. And as discussed, my first pass is of course at a 10 thousandths depth of cut. Honestly, the machine handled this with absolutely no problems whatsoever. Moving up to 20 thousandths depth of cut, this was pretty much more the same, no problems whatsoever, no major chatter to deal with. So then I stepped it up to 30 thousandths. The machine handled this 30 thousandths depth of cut so well that I actually decided to skip the 40 thousandths pass entirely. What you're seeing here is the final 50 thousandths depth of cut pass. And again, no problems here whatsoever. No major chatter to deal with. The machine just seemed to handle this like a champ. And what you're seeing here is the surface finish that I ended up with after that 50 thousandths pass. I gotta say, this machine doesn't seem to have any problems with aluminum at all. Next up is the brass, and for whatever reason, I started having chatter problems pretty much straight away in the brass. This is my first 10 thousandths pass, and I'm already getting chatter here, so what you're seeing now is basically me just experimenting with different spindle speeds. Eventually, what I wound up doing was slowing down my spindle significantly, and this is my 40 thousandths depth of cut pass at that much slower spindle speed. Things are going relatively well at this point, so I figured I could finally step it up and try my final 50 thousandths pass at that same spindle speed. It went okay. I still was fighting with some chatter. I think there's more fine tuning that can be done here, but eventually this is what I ended up with. This is the surface finish that I got from that final 50 thousandths pass. And now it's time to answer the question that I think we're all asking, which is how well does it handle steel? Again, this is 1018 cold roll. What you're watching now is, of course, my first pass at 10 thousandths depth of cut, and the machine handled this without any issues whatsoever. Stepping up to 20 thousandths, again, no issues at all, and I think at this point I'm just going to summarize a bit. So passes for 30 thousandths, 40 thousandths, and 50 thousandths. You know, obviously the steel is harder than either aluminum or brass. And taking the lessons that I learned from the brass, what I ended up doing was just paying attention to the machine and listening to what it was telling me. So by adjusting things like my spindle speed and my feed rate to get ahead of chatter when it did start, I was able to take a 50 thousandths depth of cut without any issues whatsoever, and that's what you're watching now. At this point, I figured we've already made it this far, so let's see what this thing can do. What you're watching now is a 60 thousandths depth of cut pass in 1018 cold roll steel on a 7x12 mini lathe. And honestly, this went much better than I had ever expected. So at this point, I figured, let's try 70 thousandths. And this is where I kind of got to the point where I just couldn't really get ahead of the chatter. I think with some improvements, a bit more time to experiment, this is something that's definitely doable on this lathe. But even out of the box, I was able to get through the cut, and what you're seeing now is the surface finish that I ended up with after that 70 thousandths pass. So, in summary, it works, which I guess isn't exactly an earth-shattering discovery, but, you know, coming from being used to bigger machines, I just wasn't quite sure what to expect from a mini lathe. And I gotta say that I don't want to say pleasantly surprised, because, you know, I expected it to function. I expected it to be a lathe, but I guess what I didn't expect was to be taking like 50, 60 thousandths off the diameter of a piece of steel. That I didn't expect. And keep in mind that this is basically straight out of the box. This is before any kind of improvements or modifications. Like, all that we did was unbox the machine, disassemble it, give it a good thorough inspection and deep cleaning, and then reassemble the machine with a focus on adjusting everything properly as good as we can, which, in my opinion at least, is absolutely critical. Let's just say that out of the box, this machine is definitely not going to be adjusted optimally. I can say with full confidence that if you were to just unbox one of these things, wipe off the grease and go, you are not going to get the kind of performance that we saw here today. So that first step of disassembling the machine, taking the time to get to know it, is just absolutely critical to creating a good foundation to move forward from. Which I guess brings us to the obvious question, what's next, right? Like, what about day 2? Because I think that we have covered day 1. I mean, honestly, if you were to get a new machine and you were able to accomplish everything that we have accomplished here today, ending the day with taking your first cuts, I would consider that a very successful and productive day. So what about day 2? Where do we go from here? Well, like I said, I am hoping to make a whole series of videos about this machine. So if you want to see those videos, you have to let me know. So definitely show this video some love, give it a like, and most importantly, comment below. Let me know what you want to see. Do you want to see improvements, upgrades, modifications, projects, whatever it is, any ideas that you have, put them below. Let me know that you want to see more and what you want to see more of. But in general, I'll say this. When I got my first lathe, the very first thing that I did was I spent like 2 weeks turning an 1.5 inch piece of aluminum round stock into chips. No direction, not trying to make anything but chips, just experimenting with the machine, trying different combinations of speeds and feeds, grinding different tool geometries, listening to the machine, because it'll tell you if it doesn't like what you're doing. So that would be my advice, at least for the first week or 2. Just spend some time getting to know your machine. Don't put any pressure on yourself. Just get comfortable using it. And if you get through all that and you're looking for some beginner-friendly projects to do, I have some projects on my channel with free plans available on my Patreon. Like, for example, this spring-loaded tap follower right here. This is absolutely something that you could do on this machine. So I'll leave a link to this, I guess, in this corner here at the end of this video. So at this point, I know that I'm rambling, but before I go, I think I have to at least address the question that I know a lot of people are going to ask, which is going to be something along the lines of, are mini lathes worth it? And, you know, I think that these small import machines, they tend to get a lot of unwarranted criticism, especially from people who already have access to big machines. You know what I mean? Like, it's really easy to talk crap on a 7x12 lathe when you already have a 20-inch lathe and a Bridgeport in your shop. But like I've already said, not everybody has access to that. So if you were to ask me, are mini lathes worth it? My question in return to you would be, are you interested in hobby machining? If so, and this is the machine that you have room for, or this is the machine that you can afford, or this is just the machine that you want, then the answer is going to be absolutely unequivocally yes, it's worth it. I mean, is a hacksaw worth it? Is a file worth it? Is a strip of sandpaper worth it? I mean, do you want to make something? Are those the tools that you have access to? Then yes, they're worth it. Pick them up and make something. Anyway, I think this video is probably already like 7 hours long now, so if you've made it this far, thank you so very much. I do really appreciate it. If you want to check one of these out for yourself, I'll put some links and discount codes below, and I'll leave a link to that spring-loaded top follower somewhere in the corner down here. If you like this video, don't forget to like and comment, and definitely let me know if you want to see more about this mini lathe. Anyway, thanks again. I'll see you next time.